Hello, and it's Mr. Trochet with another video lesson 9.1.1 in the core connections 2 for CC2, for which is the 7th grade book. So what we're going to do today is we are going to get started. Now, this is going to be really difficult to do distance learning already, but just going to do my very best. I want to go over a few things. We're going to go over circumference, we're going to go over diameter, and we're going to go over pi in terms of a circle. So sometimes I don't know why my pen doesn't work, but so the first thing is, let's just pretend real quick that we have this can of tennis balls, right? So we know it's cylinder. It is a cylinder, right? And then one way you can do is you can wrap a string around the can and cut it. So let me use a yellow. So let's say I have this string right here, and I'm going to wrap it around, going behind it. And then it matches right here. Now, what you can do is when you wrap a string around the cylinder or anything that is round in a circle like this, that is called the circumference. Circumference is that right there. Sometimes I don't know how to spell. Circumference of a circle. And that is basically going to be around the circle. Okay, that's going to be around the circle. And that's one thing that you want to know. Now, if I were to measure this right here and compare it, and if I took that string that I wrapped around, so I wrapped it around the can, and I got this circle. If I were to stretch it out, how long would that be? And so would that same piece of string along the can's length compare? And would that be shorter or longer, the same length? And that's kind of one of those things where it depends, actually. So if I took this string and I actually unraveled it and I measured it this way, it could be longer, it could be shorter. Because as we know that, for example, where is my my example? So here's paper towels, right? So this is a pretty small inner circle. So if I wrap it around this way, it's definitely not going to match the length of this paper towel holder. That's for sure. So it all depends. But we're going to go ahead and get into more depth. So circumference is around. All right. We're going to go to the next one. Here is the circumference definition, is the perimeter. Again, distance around of a circle. And the next one that we want to, mouse, click, pen, clear. The next one that we want to do is we want to get an idea of what the diameter is. And the diameter is, well, here's the definition, but I'm going to tell you my definition in a quick second. So if you want to pause, go ahead, pause. But pen, clear, remove, mouse, click. Okay. The diameter is when you have a circle, it is the measurement of the entire distance through the center. So here's the center. It is from one side of the circle to the other side of the circle. It is the length from one end. So let's just put A to B. So here is use black. Here's the one side of the circle. It goes all the way to this side of the circle. So for the diameter is the length from one side of the circle to the other through its center, right there. Now they're asking us to do this this little bubble wand thing, which I think is an amazing opportunity to do, but it's really hard to do over distance learning, and just with COVID and everything, blowing bubbles is probably not the safest thing to do. But anyways, we're going to go ahead and do this. It says you're going to blow a bubble and you want it to land on the paper, right? And so what does that do? When it lands on the paper, it leaves a print and it leaves a circle, but we want to understand what it's doing. So if I were to have a paper, right? And let's say my paper is, let me just fill it black right here. Here's my paper, and I blow a bubble, and my bubble is falling, and it lands right here. That would be my bubble. and that would be a measuring of the entire circumference of where it landed before it popped. And also we can measure the diameter. All right, so again, we can measure the around measurement and the diameter, and they're probably going to be different sizes. So let's go ahead. It says wrap a string carefully around the circle and then stretch it along the meter stick to measure the circumference. And unfortunately, we can't do that right now. But then if you measure it across the circle, that is the diameter. So those are the two things. So again, circumference is around, diameter is straight through the center from one side to the other. Just little definitions, but we'll get into measuring soon enough. All right, so it tells us to blow 8 bubbles. Fortunately, we can't do that. Unfortunately, I don't have any bubble things as well. And then we're going to go on to 9.3 real quick. It says, explain some of these ideas. So how can you use your graph to show that circumference and diameter are related proportionally? We will get into some solving later on to discuss how that is and how proportional it is or how the relationship is. And then it says, find out what the multiplier is between the diameter and the circumference. So for example, if I had a circle with a circumference of, let's just go ahead and say a circumference is, let's say, 22 inches, all right? And then we would have, what would our diameter be? Right? And then there's ways to solve that. There's ways to solve that in order to find out what the relationship is between those. All right, and we're gonna dive into that a little bit later, but let's continue on. So if a diameter of a bubble were 9 centimeters, predict what the approximate circumference is without measuring it. So in order for us to do this, we're gonna go ahead and learn a few things. So circumference, there is a formula, which is 2 pi r. And you're probably wondering what this pi is, and they actually tell us in a little bit, but I want to just get a head start. Pi, as it's pronounced pi, is an irrational number. And I'm just going to kind of give a head start on this. It's usually about 3.14. Oops, I messed up. 3.14 or equivalent to 22 sevenths, all right? And that is going to be an irrational number, which means that there's no way to write it as fractions with integers, but this is as close as we possibly can get to. 3.14 is the shortened version. But anyways, as we were saying before, 2 pi r, r is called the radius. And then our radius, if I have a circle and we know that diameter is the distance, which is d, we're going to say d is diameter. D is diameter. Then that means radius is from the center to one side, which is half of the diameter. So again, so r equals 1/2 of the diameter, which is we're going to say is d. All right. So let's say, what is that going to equal? If a bubble were 9 centimeters, and that's the diameter, what is the approximate circumference? Well, if we know the diameter is 9, that means d equals 9. That means the r would equal 4.5, right? So what we would do is we'd say circumference is 9 centimeters. And that is 2 pi. And we know that our diameter, let me go ahead and erase this part right here. So the diameter is 9, so that means the radius is 4.5. Approximate the circumference. Well, the circumference is going to be, circumference equals 9 pi. So that means 9 times 3.14, and then we would just do the math there. So for example, 9 times 3.14, we can say it's about 3, so it should be about 27, probably up to 28 because of the 0.14, and that's kind of the ratio. So if we were doing the blow the bubble kind of situation, you would say it kind of increases by 3. So the relationship between the diameter and the circumference would be about 3.14. That's what would be the approximation. So let's actually look at Google. So let's say the diameter of a circle, diameter equals 9 centimeters, right? That means the radius here is 4.5, as we said, and the circumference is 28.3. So going back to what we said here, oops, where'd my CPM go? Going back to what we said, yeah, we said 27, 9, 18, 27 because it's 9 times 3, but the 0.14 is just a little bit over, so we said 28. All right, so basically, to answer the question, as we wanted to go back here, let me go back up here. It says, what is the multiplier between the diameter and the circumference? And so we can say about, come on, what's going on? About 3.14. You can say times 3, just around there. And so that, how is that related? Why is my thing not writing? What is going on? Related proportionally, it's basically times 3, if we had to give a guess. Okay. Going on to, let me go ahead and erase everything. All right. So now we know that the ratio of circumference, I don't know what's going on. The ratio of circumference to diameter of a circle has been measured with an increasing accuracy, which is slightly greater than 3. I know that's like the exploration part. But let's see. Write down the decimal equivalent for pi. We said 3.14. And the fraction, this is often used to approximate what is the decimal equivalent. Well, let's just go ahead and just do this. We'll go ahead and, clear, enter, 22 divided by 7. And that is 3.142857, 14286. So 3.14, again, is our answer. And that's what you're going to be using a lot. 3.14 to the nearest hundredth. 4. All right, moving on to our next stuff. So let's keep going. All right, work with your team to generalize the relationship between circumference and diameter of circle. In other words, describe how you calculate the circumference of any circle if you knew the diameter. So basically, if you knew the diameter, what you would do is you would do the diameter times 3.14, and that would give you your answer. All right. How could you find the length of the diameter if you knew the circumference? Well, if I needed to find the diameter, then what I would do is I'd solve, and I would just go ahead and do this. I would divide by 3.14. This is circumference. I don't know why it's not writing. Maybe my pen is dying. Give me 1 second. Oh, is my pen dying? I don't know. Okay. Circumference. And then you would divide by 3.14. Yeah, my pen was dying, that's all. Because this crosses out, then we're left with D equals C divided by 3.14, and C would be circumference. So that's how you would find circumference, would be this equation right here. And then to find diameter would be that equation right there. Just simple, basic ways of solving. All right, now return to your prediction of 9-1. Discuss it with your team again. Has your prediction changed? We didn't do really 9-1, or did we do 9-1? Yeah, no, we said it wasn't going to be the same length, and it's not. It's 3 times. So that's pretty much it. All right, so overall, here's the main points that you need to know for today. So we're going to say D is going to equal, why is it diameter? R is radius. C will be circumference. And then we have pi is 3.14, or it's 22/7. Either one works. And in order to find the circumference, it's 2 pi r, or it is C equals pi d. And because 2r 2r equals d, because if I had a circle and I did that, oop, there we go. Why is it r? Well, then what's 2r? Well, then that would be r over here, and 2r would equal the diameter. All right, so that's why it can be either this or it can be 2 pi r here. Those are the things you need to know. Those are the things you need to write down in your notebook. And that's pretty much it. So hopefully this was helpful for 9-1. Good luck on your homework. And if you have any questions, please let me know at office hours or after school. Thank you so much. Have a great day.